Hello, happy people of the pre-calc world. This will be our first video for our virtual lessons. This is how it's going to work. I'm going to go through the slides I would have given as notes and do the examples. And remember, everything on Brightspace is there to help you as well. So we're just going to get going with simple limits. So for this first slide, you might want to pause the video so you can write it down and sketch the graph. So a limit is just a value that a function approaches but doesn't really equal. So like when we had asymptotes with trig functions, those are values that functions approach but never quite get to. And so we want to know what is the function doing and what number is it getting really close to, and that's where limits come in. And today we're going to start with simple limits that just have numerical answers. So today for our limit, we're going to have a limit that goes to a number. We're not really going to do infinity or negative infinity today, but we'll get to that later in our chapter. And we're going to take a limit and we are going to get a number value. So we've done some limits before. We know that the limit to infinity of a number is just that number. So that stands true for a limit to a number. It's still a number. And if we have a limit to a number for a function, we're just going to plug that number in. So again, you might want to pause the video so you can write this down. And then I'm going to stop talking for a few seconds so that you can do that. And then we will get going. So again, you can solve a simple limit by using direct substitution. So we're going to fill in the number as long as the denominator is in 0. So for our first example, we do not have a denominator. So if we're going to find the limit as x approaches 2 of 2x cubed minus 6x squared minus 10x plus 10, all we have to do is plug in the value we are going towards. So we're going towards 2. So we're going to take 2 times 2 cubed minus 6 times 2 squared minus 10 times 2 plus 10. And if we do that, we get a value of negative 18. So that is actually our answer here. Our answer is negative 18. So all we're going to be doing today is taking limits of numbers, which are those numbers, or limits of a function where we plug a number in, just like this example. All right, so I have 2 examples for you. You might want to pause the video and try them on your own. If not, you still don't know what's going on, that's okay. We'll do them together. And these are actually the only 2 examples I have for you, and then you will do the worksheet for today. So if we are going to find the limit as x goes to 20, x for 15, remember if we take any limit and it's just a number, it always just equals that number. So in this case, our limit is 15. And we learned that way back when we were talking about infinite limits, way back when we were talking about end behavior, which we will talk about more next week. All right, the second problem is a lot like the one on the last slide. So we have the limit as x is approaching 2 of negative 4x squared plus 2x minus 5. So since x is approaching 2, we're going to put in 2 and substitute that for all our x's. So we're going to have negative 4 times 2 squared plus 2 times 2 minus 5. And if we go ahead and put that in a calculator or figure it out in our head, we are going to get a value of negative 17 for our limit. So again, today we're just doing simple limits. This is all we're doing. You're going to have numbers, or you're going to have to plug your number in. You will not have any today that will have a denominator of 0. We're going to talk about that tomorrow. So remember to do your homework, take a picture of it, and share it with me. I hope you are safe. I hope you're healthy, and I hope you all have a great day.